Hello, this is Mr. Collier, and today we're doing standard deviation and variance. Okay, so we've already learned about range and interquartile range, which are measures of how spread out data is. So today we're going to look at variance and standard deviation. So let's take a look at this set of numbers. First of all, if you get the mean of these numbers, the mean is actually equal to exactly 10. And well, another way to look at the way the numbers are spread out is to see how far away the numbers are from 10. So like for example, the number 6 is 4 away from 10, and the number 12 is 2 away from 10. So we can look at these kinds of relationships. Okay, so I'm going to start by making a little table here. So we're going to do this by hand and then use technology, because this kind of stuff can get pretty tedious. I'm going to write the x values in order, but you don't have to do this. I'm just going to do that to keep myself organized. So we've got 6, 8, we've got 2 9s, we've got 2 10s, we've got 11, and we've got 12, 12, and 13. Okay, and then I'm going to make another column called, well, you can call it the deviations, like how far it deviates or how far it's different from the mean. So we'll call that deviations, or basically what we're going to do is the values minus the mean. Okay, that's how we get how far away it is from the mean. So 6 minus 10 is -4, -2, -1, -1, 0, 0, 1, 2, 2, 3. Okay, so notice I got some negative numbers here, right? And so if I subtract them, imagine myself doing this on a spreadsheet or something like that. I'll just have to type in like one cell, subtract another cell, so it'll spit out these numbers here, right? So one way to make these numbers all positive, to indicate a distance away from the mean, is to just get the absolute value of these numbers. That would make all these numbers positive. Another way to make all these numbers positive is to square the numbers. So what we can do is we can get the square of the deviations. Okay, so we're going to take the square of all these numbers, and it will make all these numbers positive. So we have 16, 4, 1, 1, 0, 0, 1, 4, 4, 9 are the squares of the deviations. Okay, so we have all those. Now, if we want to find out how far in general these values, how far they deviate from the mean, or how far they're different from the mean, we can get the average of the square deviations. Okay, so I'm going to add all these up, and then I'm going to divide. So actually I can add them all up. If you add them all up, you get 40. Okay, so the sum is 40. Another way to write sum is this. Okay, this is the summation of x minus the average squared. So if I add them all up, I get 40. And how many are there altogether? There are 10 values in this data set. So to get the average, I divide by 10. Okay, so if you do this calculation, you get a 4. So what I did is I took every x value, subtracted the mean, squared those values, added them all up, divided by 10, and I got this number 4. Okay, and this has a name and a symbol. This is called variance, and the symbol is sigma squared. That's the Greek letter sigma. Okay, so this is the variance. But remember now, here we had like 6 was 4 away from the mean, and 8 is 2 away from the mean. So these numbers are all a bit too big. They don't really indicate on average how far away these numbers are from the mean. So what we could do is we can square root this. Okay, so I'm going to write this like this. Square root of the sum of the x minus x bar squared over, I'm going to use n to be a bit more general, so n is the number of data values. So this is what we call the sigma, or the standard deviation. Okay, standard deviation. Okay, deviation just means like kind of how far these numbers are away from the mean. And it's standard deviation. I kind of like standardized this variable by taking the square root because I'm now back to the same scale as these numbers over here. So if I do the square root of 4, so in this case I'm going to have sigma, or the standard deviation, equals 2. Okay, this means sort of on average these numbers are 2 away from the mean. So that is how you calculate standard deviation by hand. Now, of course, if you got hundreds of these numbers, it's not really feasible to do it by hand, so we're going to use technology as well. Okay, so many computer programs and spreadsheets can easily calculate standard deviation and variance. We're going to do that now with a TID4 calculator. Okay, so I'm just waiting for that to open up, and so on the TID4, if we want to do any statistics, we're going to type in the data onto a list. So I'll go to Stat, Edit, and I got stuff in there already, so I'm going to clear these lists. Do not press Delete, or you'll delete the whole list. Press Clear on L1 and L2 and you get it all cleared out. I just need to type in these numbers, so 13, 6, 12, they don't need to be in order. 10, 11, oops, I'll go back and fix that. 11, 9, 10, 8, 12, 9. Okay, so next I will just go to Stat, go over to Calc, and one variable statistics will give you all the information. Make sure this is just L1 and there's nothing in frequency list, because we have no frequencies here. So it gives you the average, which is 10. The sum of the numbers is 100. And if you scroll down, you get the 5-point summary that you can use for box plot. They got the quartiles and everything. But right here, the sigma symbol tells us the standard deviation, which is 2. Okay, so it's going to work slightly differently if you have group data. So in this group data, we have 3 11s, 4 12s, and so forth. So it's 50 values in total, and let's see how to do that on the calculator. When we go to edit here, I'm gonna clear this list. Hang on. I will type in these scores, so 11 on up to 19. So 11, 12, 13, 14. Oops. Back, fix that. Okay, it goes on up to 18, actually up to 19. And L2 will be my frequencies. So I have 3, 4, 5, 2, 8, 9, 5, 8, 6. Okay, so now we go to statistics, and we go to calculate one variable statistics. I will put L2 into this frequency list. So you can L2 is down here over the 2 button, so you press second 2 and there it comes, and then press enter, enter, and here you got the average of the numbers, and n equals 50, so that's a good sign because there's actually 50 numbers in this list. 5-point summary, and here is the standard deviation, it's 2.38.